Hello everyone, welcome back to our channel. Today we are going to discuss another problem from the CSES problem set. Without wasting any time, let's dive into the problem statement. So in the problem, we are given with n cities and there are m roads between them. And all the roads are in the poor condition and needs repair. With each road has a reparation cost. Now we need to repair the road such that there is a path between any two cities. And also we want to minimize the total reparation cost. Now let's understand this problem statement with the example test case that is given. So if we make the graph for this test case, for we have from 1 to 2 we have the cost 3, for 2 to 3 we have the cost 5, for 2 to 4 we have the cost 2, from 3 to 4 we have 8, from 1 to 5 we have 7, and from 5 to 4 we have the cost 4. So if I start from this vertex 1 to reach the vertex 2, I'll repair this road because this is the minimum node from 1. From 2, I'll take the node 3 and I can also go to node 4. So I will take this, both are the minimum distance to reach 3 and to 4. So I'll take 4, 2 and 5. I'll repair these because these are the minimum costs which I can make to reach these nodes. And from 4, I can go to node 5 because 3 is already being repaired by this edge. So I'll discard this edge. And to 5 I can repair with this node because this would take me the less cost than using the 7. So I will so my path would look something like this. This was the path that I would follow, and the total cost for repairing this would come up to be 3 plus 5 plus 2 plus 4, which is equals to 40. So this is the output. So this is the output that we have received. So now from this example, we can understand that we are actually starting from a vertex V and moving to all the vertices and selecting some subset of the edges so that I can reach from any node V to any node U by any path. So isn't that remind us something called the MST, which is known as the minimum spanning tree? The minimum spanning tree states that a subset of edges that connects all the vertices with the minimum possible total edge weight. So we have got the subset of the edges and with the minimum edge weight with which we can reach all the which we can visit all the vertices. So to find the minimum spanning tree, we use the Prim's algorithm, or we can use the Kruskal's as well. In this video, we are going to discuss the Prim's algorithm of how we are using this Prim's algorithm. Yeah, so Prim's algorithm. So in the Prim's algorithm, we would be starting with a start with any vertex. Let's start with 1. Let's start with 1. Now we will use the priority queue. We'll use the priority queue to select the minimum cost edge from 1 to its adjacent edges, and now we will add that minimum edge to our MST, which connects to the new vertex, and then we will repeat this complete process. Repeat complete until all nodes are reached. Now let's discuss the code for this, how we can write the code for the Prim's algorithm to find the MST. Now we have taken the input a number of nodes, cities and the number of roads, and then we have made the adjacency list out of it. So we have given with the bidirectional roads. Now we have made a visited array which would maintain the visited, whether the node is visited or not, and we have made a min heap priority queue, like it's a min heap, and we are starting with the node 1. So we have pushed the cost for node city 1 is to be 0, and city 1 from where we are starting, and this is how the code for Prim's algorithm is being there. And finally we are checking if if all the nodes are not visited. So our MST is not possible, so we will print the impossible case, and if we have got that all the nodes are visited, we would be finally printing our array. So this is how our answer would be. If you find the explanation helpful, please hit that like button and subscribe to our channel for more algorithm explanations. Drop your questions in the comment below and let me know which CSS problem you would like me to cover next. Thank you for watching. I'll see you next video.